Let us now start with the amplitude modulation, the first type of modulation technique that we are going to discuss. We will discuss many things about amplitude modulation in its introduction part. Later on, we will discuss amplitude modulation in detail in terms of generation, reception, its various types, etc. In the introduction part of amplitude modulation, we'll be referring to amplitude modulation as AM. So in its introduction, we will first start with the waveforms. Let's see how amplitude modulated signal will look like. All right, and this waveforms will also help us to understand the amplitude modulation process and define it. I've already said that in amplitude modulation, we will be putting the information signal in the amplitude of the carrier signal. Now let's start with the waveforms. The information signal is low frequency signal, and for the very first time we will give information signal another name. So the first waveform that we have drawn is nothing but information signal, and in the process of modulation, information signal will be called modulating signal. So the very first waveform that we have taken is information signal, which is called modulating signal. Now as you can see, it's low frequency signal compared to the second signal that we have drawn. We'll come to that signal, but before that, for simplicity of entire process, we have taken modulating signal or the information signal of single frequency. So it is single frequency signal. It could be let's say 50 Hertz signal, it could be 100 Hertz, it could be 1 kilohertz signal, it could be 10 kilohertz signal. It will be one frequency from the range 20 Hertz to 20 kilohertz. Let's go to the second waveform. The second waveform is, you can see, high frequency signal compared to the first one. That's because it's carrier signal. So the second signal that we have drawn is nothing but the carrier signal. So in the previous video clip, we had shown a modulator block to which there are two inputs: information signal, which is also called modulating signal, and the second input is carrier signal. Let's define the process of amplitude modulation. It is a process in which the amplitude of the carrier signal will be changed in proportion to instantaneous amplitude of modulating signal, keeping frequency and phase of the carrier signal constant. I repeat, we will change amplitude of the carrier signal. Now when I say we will change the amplitude of the carrier signal, it will be changed in proportion to the modulating signal. So when the modulating signal increases in its amplitude, the carrier signal amplitude will also increase. So as you can see, the third waveform is nothing but amplitude modulated signal. So let's verify how the third signal is amplitude modulated signal. As the amplitude of the modulating signal is increasing, you can see that the carrier amplitude will also increase in the beginning. When the amplitude of modulating signal is at its peak value, the amplitude of carrier signal will also increase to its peak. After this, you can see the amplitude of the modulating signal will start decreasing, and hence amplitude of this carrier signal will also start decreasing and go to its minimum value. Again, after that minimum value is passed, modulating signal amplitude will increase and the carrier amplitude will also increase. So if you look at the third signal, the third waveform, in the third waveform we have basically changed the amplitude of the carrier signal in proportion to the amplitude of the modulating signal, and hence if you look at the new peak values of the carrier signal, they are not constant. Earlier the peak value is constant. Now the peak value of every cycle is changing in proportion to the amplitude of the modulating signal. So for a moment, if you just look at this upper part of the third signal, this upper part which is called envelope of the modulated signal, so the locus of all the peaks of the third signal is called envelope. So if you look at the envelope, now there are two envelopes. The lower side of the signal is called negative envelope. Both are the envelopes of the signal. This is called positive envelope. This is called negative envelope. So you can see, if you look at the positive envelope, the shape of the positive envelope resembles exactly to the modulating signal. So what have we achieved in this third signal? We have simply put the modulating signal into the peak amplitudes of the carrier signal. So if you now look at the new peak amplitudes of the third signal, in the third signal the new peak amplitudes will give you the shape of the modulating signal. Now if you observe carefully, in drawing the third waveform, we have made some assumption. The peak amplitude of the first signal, which is modulating signal, is AM. The peak amplitude of the carrier signal that we had taken is AC, and the assumption that we had made is AM is less than AC, and because of that you can see when amplitude in the third signal increases and decreases, you get an envelope which is not touching the x-axis. That is simply because up to this level, the dotted level which you have drawn, up to this level from the horizontal axis will be your amplitude AC. Above AC the signal will increase up to AM, and below this line again signal will decrease up to AM. So these two arrows that I have drawn correspond to the amplitude equal to AM, and because AM is less than AC, the positive envelope and the negative envelope, they are not touching each other. Whereas if you take an assumption that AM is equal to AC, let us see what is going to happen. If AM and AC are exactly same, in that case the reduction in the peak amplitudes will become zero at particular point of time when modulating signal takes the minimum negative value, and in that case this lowest peak of the positive envelope will touch the x-axis, and the maximum peak of negative envelope will also touch the x-axis. So the waveform that we will get will look something like this. So the fourth waveform is also amplitude modulated waveform, but that is drawn assuming that AM and AC are exactly same. So now if you can make out, if AM is very small, then both the envelopes will be very much away from each other, and if AM is equal to AC, you can see both the waveforms will touch each other. We will see what happens if AM is greater than AC. Before that, we understand one thing, that relation between AM and AC is very important. We define a parameter called modulation index. We will discuss modulation index in detail later on, but this parameter is defined as AM by AC. AM is the peak amplitude of the modulating signal and AC is the peak amplitude of the carrier signal. So if AM is less than AC, then modulation index, which is written as small m, will be less than 1. If AM and AC are equal, then modulation index m will be equal to 1. So in this video clip, to summarize, we defined the process of modulation and we saw the waveform of amplitude modulated signal.